Today we'll talk briefly about MISRA and then mostly about your test process and how we should be doing our job properly. The obligatory about me, but you've heard all that already, so there we are. You recognise this slide. I created the original. I didn't know Ian was going to use it, so I've updated it a little bit to show a little bit more of where LDRA are involved within the standards community. So software quality, which I will be talking about a little bit, the general life cycle, which today I won't, software testing, which I will be. And then, of course, as was already on the slide Ian presented, we have the functional safety and security in the automotive world and the various programming languages at the other end. And I've got Ian's cheers slide on this screen, so I need to look over there. So in this, I'll be talking about three main topics. Briefly, given I'm the chair of MISRA C, I was told I had to talk about MISRA C, so I will briefly. 29119, and then about the quality measures. So, the latest news out of MISRA C. And I'll quickly speed over the evolution of where we got to today. So, way back in the mists of ancient time, the first edition of MISRA C was published in 1998. There we are. And that was guidelines for the use of the C language in vehicle-based systems. It was created by the automotive industry for the automotive industry. But one of the first questions when it was published was, is there a similar thing to MISRA C for medical? And people looked at each other, scratched their heads and say, well, what's wrong with MISRA C? It says, well, that's for vehicle-based software, we can't have that. So a few years afterwards, the second edition was released, which perhaps more importantly than anything inside the cover was the cover itself. It became guidelines for the use of the C language in critical systems, any critical systems. That sat around for a while until in 2012, the third edition was published, which we then updated with some additional security rules in 2016 and consolidated that into a new book in 2019. That then went through some fairly quick updates to add in C11 in 2020. Then we started addressing some of the questions that we'd received from our bulletin board, update in 2022. We had a nice quiet couple of years for COVID. Amendment 3 started to add in all the new features for C11. And then last year we published Amendment 4, which finished all the C11 and then C18 changes. Originally we'd planned that we would produce a new version of the book in 2024. But while we started to consolidate this, somebody pointed out that 2023 was the 25th anniversary of the original book. And so we quickly produced the new latest version, MISRA C 2023. You can order that through the MISRA website as a PDF, or a new thing for MISRA, you can now buy it through Amazon. And a quick run through from that third edition in 2012, where we had 16 rules and 16 directives, 143 rules. As you can see, we've added more and more features until this final version has 200 rules and 21 directives. Work is underway at the moment, and hopefully next year there will be a new version with some additional rules and some improvements to the existing guidance. It will not include the newest version of the C standard, which has been laughingly called C23 up until yesterday, where ISO have cancelled the project because it's run out of time. So we need to work out what's happening with the C standard and exactly how we move ahead with that. Within MISRA, though, there's more than just MISRA C, so we have some guidance. C Secure and CERT, which Ian has already mentioned, we have published mappings of those to MISRA C. They're both in the process of being updated for the new version. And we're also looking at 2 additional mappings, the Language Vulnerability Standard that came out of the Languages Working Group, and again, has been mentioned, the CWE. And then MISRA compliance. That's a talk all on its own, and maybe we'll do that next time. So software testing. It should be an integral part of every development lifecycle, whether that's agile, V, waterfall, whatever. And should be planned and scheduled and resourced as importantly as every other part. However, we all know that testing gets pushed to the end, doesn't get scheduled. You run out of time, you run out of budget, so we don't worry about it so much. What could possibly go wrong? And arguably, it becomes a black art. You have a few specialists who do the clever stuff. It's not a documented process. The magic wand is waved, the software is tested, a report is generated, it shows green, the management are happy. A few years back, it was decided that while the ISO software development lifecycle included testing, it basically said, do some. We decided, actually a standard was probably a good idea. There's good reasons for having standards. They define guidance that everybody can understand, everybody can follow. Governments like them. Tool vendors love them because it means we can charge you a lot of money for a report. The purpose is to define what goes on. Standards are not there to dictate. Standards document good or best practice. And all standards actually have ways that you can tailor them to adapt them to your circumstances. You do not blindly follow a standard exactly as it is just because that's what the standard says. You need to understand what's going on. So, way back when, the Americans created a MIL standard on software development life cycles. They then created another one because the best thing about standards, the number there are to choose from. They modified it again. It got more and more prescriptive. So MIL Standard 498 actually included templates for every document that you had to produce. Then industry started getting on this and thinking, this is just too prescriptive. We need to be a little more flexible. Industry didn't like these. Software developers don't like them. People sometimes don't like being told what they have to do. We're experts, aren't we? We want to do it our way. 1994, Perry, who was the Secretary of State for Defense, decreed that the military would stop producing their own standards and the industry should produce them. And the result was that ISO 12207 was adopted and all of those were deprecated. That's way back in 1994. It's still surprising how often MIL Standard 498 is called up as a requirement in projects in the military space. At this time, there was a whole plethora of testing standards. The most commonly used, and we have reps from IEEE here today, were actually 2 British standards and a set of IEEE standards. And there are other IEEE ones in the mix as well. So it was agreed that we would take these and create a harmonized set of standards for software testing. Because, if If you've got lots and lots of competing standards, what's the best thing you do? You create another new one. So you now have another extra competing standard because we don't get rid of the old ones. So the result is ISO, IEC, IEEE, because the IEEE are involved with this, 29119. It started out as a 5-part standard to consolidate all of these IEEE and British standards, removed the discrepancies and harmonised them. 2 additional standards were then created. 20246 is your review processes, which sort of adopts many of the good things of the previously unstandardized review processes, but drops a lot of the absolute bureaucracy that things like Fagin reviews gave you. And 33063 is an ISO standard for evaluating your test processes. But 5 parts isn't enough, we need more than that. So we've extended into Agile, because Agile's a nice buzzword, we've got to be Agile, haven't we? AI systems. You know, how do you test an AI system? Anybody want to put their hand up and tell me? Because I helped write the standard and I'm still not sure. Biometrics. And then there's a whole list of new parts, particularly at the bottom there, part 15 on static analysis, where some idiot is writing that one. Interestingly enough, and I mentioned this earlier about with the original standards, some people didn't like having a standard. So when 29119 was first being published, a group of American testers got together and petitioned ISO to have this standard withdrawn. They did not like the idea of having standards for software testing. We're back to the magic. Their expertise was more important than industry having a standard. They said there is no consensus for 29119, which is interesting because both for the first edition and the first 5 parts have been updated. Out of the 65 national bodies that are part of ISO, we had 0 countries voted against. Now, if that isn't consensus, I'm not quite sure what is. So, consensus does not imply unanimity. However, if you get no votes against, I think that's all right. So, what does 29119 tell you? Well, in a simple way, it tells you to do what I hope any good software engineer is already doing. There isn't really magic between writing, developing, testing software. Mostly it's common sense. As an organization, you will have some processes. As a project, you will have some test management processes. As a project, you will have some test execution processes. As I mentioned, part 15 will bring static analysis into this, and actually will have a very similar structure to what part 2 has. So how do we test? Well, let's understand the context. What are we trying to test? What do we want to achieve? We do that anyway, don't we? A few heads please nod and say we are doing that. We then organise our test plan. A test plan does not have to be a 2-inch book telling us what you're going to do. None of these need to be documents per se. They can be in a tool, in a wiki, however you want to do it. You want to identify and estimate the risks. What are the real problems you're looking for? No? Will your code fit into the processor you've selected? Is always a good starting point. Do you have enough power to execute everything? What is your execution time? How do we deal with those? We then design our test strategy. This is all common sense, isn't it? There's nothing here that's too controversial. Determine staffing and scheduling. Project Management 101. Who's going to do it? When are they going to do it? What facilities do they need? Agree it all and do it. That's your plan. Nothing magic there, is there? How do we do our testing? Design our tests, set up the environment around them, execute them, log any problems. Easy. No magic. So, ISO, IEC, IEEE 29119. It consolidates a significant number of standards that existed into a set of coherent, consistent standards. Some people didn't like that. It brings together the international community to agree globally a set of processes. They will evolve. They will get better. The working group welcomes new members. So at the moment, there are no members of India National Body in Working Group 26. Maybe one or two of you would like to talk to your national body and get yourself nominated. No. It is important for each country to have their voice heard. So, it's a standardization of a process model. It is not a prescriptive standard to say how you will test things. It guides you in what you should be doing. But in amongst all of this, and linking back to MISRA, how do we measure the quality? In England, we have this phrase, when you don't know something, you just say, how long's a piece of string? How long will it take? Oh, piece of string's that long. Is that good? Is it bad? All we know is that long is twice as long as half of its length. How long's a piece of string? We don't know. And that's the same, actually, with a lot of measures. There's a phrase that was attributed to a management guru called Peter Drucker. If you can't measure it, you can't manage it. He actually never said that, and unfortunately, that phrase has become a central part of a lot of QA and a lot of metrics. He didn't say it, and he didn't actually say that. However, a guy called Edwards Denning, many, many moons ago, said, "It is wrong to suppose that if you can't measure it, you can't manage it, a costly myth." So actually, the correct phrase is the opposite of this, if you can't measure it, you can't manage it. However, in the mechanical world, measuring things is easy. We get a measurement out and we check the dimensions. There's a drawing. There's all the critical dimensions. There's diameters, tolerances, whatever. And you can look at a drawing and you go, yep, tick. Does it comply with the drawing? Yes, no. If no, you can concess it or you reject it. In software, how do you do it? Scott Adams with Dilbert comes up with the answers to many things, and a colleague of mine found this quite hilarious because Mr. Pitchford was writing a newsletter when this one came out. You can create measures of absolutely anything. A lot of them are useless. So the number of words you write is not a very useful metric. In software, you can't measure the physical characteristics of the software. I have this here as a joke. I was working for a company a few years ago. It was the first time they had produced software. I released the software to the production team to be burnt onto some chips. The phone went. I need a drawing of this part number. That's the software. I need a drawing. So I called over one of the mechies and said, have you got a stock image of a CD? Yes. Put it on a drawing sheet, I'll sign it off. Production were happy they had a drawing of the part. Completely useless. So how do we measure software? As in all good things, there's an ISO working group that talks about measures. So this is working group 6 of SC7. And they've come up with a whole array of possible metrics. And I'm going to focus here on maintainability, because actually they're the ones that really matter to me in software. And you can look at how do we measure maintainability. So reusability, we've recently moved out the way to a different group, because that isn't really part of maintenance. The fault proneness actually maps directly to the MISRA characteristics. And, of course, good tools will give you lots and lots of measures. I'm probably going to get my wrist slapped because this is from version 9 and I ought to have updated it to version 10, but it's all right, there's nobody important in the... Oh, sorry. So you get a green if it's good, red if it's bad. But what do we mean by good or bad? Professor Goodhart was an economist in the UK government, an economist, not a computer scientist. And he came up with a phrase in the 1970s, when a measure becomes a target, it ceases to be a good measure. So, cyclomatic complexity must not exceed 20. Good, bad? Lines of code must not exceed 50 in a function. Good, bad? Test coverage shall be 100%. Good, bad? A lot of standards talk about complexity. So here we have ISO 26262. It is a highly recommended requirement that you look at complexity. But what do we mean by that? 26262 does not tell you anything else. Could mean your algorithmic complexity. How complex is your algorithm? Well, that's probably a given. Your operational complexity, tasks, I/O, again, probably not much you can do with that. Your modular, how many files, modules, header files, build files, data files. Size, cyclomatic. Typically, when we talk about complexity, we typically mean cyclomatic. But don't assume. If you have a program, think about the number of source files. One source file makes things simple in one hand, but hugely complex in another. If you've got multiple files, how do they interact with each other? So you're looking at your coupling and your cohesion. Libraries may have low cohesion and high coupling, which goes against the grain. But actually, that's not a problem because they're libraries. So again, always think about the measures. Back to our how long's a piece of string. People often talk about source lines of code without really thinking about what they mean. I'm going to have to speed up a bit. Lines of code is probably the most useless measure ever. So, most companies have a requirement in their coding standards that a function shall be no longer than XX files. Anybody going to put the hand up and say, yes, we do? Anybody going to be brave and do that? Yeah, it needed one and the rest of you did, thank you. A lot of companies, that number is 52. Do you know why it's 52? Because in days of old, we used to print it out on green and white striped paper. And there are 52 lines on a sheet. Right? And it was, a function shall fit on one sheet of paper. That's where that number comes from. I would hazard a guess it's 30 years since somebody printed code out on one of those, but they still have a no longer than 52 lines of code. And I've got 13 seconds, so I'm going to overrun, sorry. Now, you could write some code like this, because your agenda said I had 40 minutes. You could write some code like that, which is nice and clear, has a comment, whatever. That has a number of lines of code, logical lines of code, comment lines of code, and blank lines. Or you could do that. Exactly the same functionality. Which code is more clear? If you've got a requirement for 52 lines of code and you're 56 lines of code, what you do is you take out the blank line, you take out the comment, you squeeze it up, and your code is completely less clear. So think of metrics and think about them again. Jurassic Park. The only time I can find where source lines of code is mentioned in sort of popular media. You know, the geek who was corrupt. 2 million source lines of code. Should I be impressed by that? So, cyclomatic complexity is keep it simple, and I will scoot through these because my time is up, sorry. Keep your functions small, make them one function. We can then test, we can maintain them, we can understand what's going on. Alternatively, you can have utter spider's web of code. This is from just a piece of open source code. That's not the problem. It's open source, which means I can talk about it in conferences. This function here has a complexity of 90-something, 98. All we know is that code is completely unmaintainable. We can't test it. You know, keep it simple. The Toyota unintended acceleration case in America a few years ago, my lawyer reminds me to say, Toyota were cleared of any technical wrongdoing in that case. They only received a $4 billion fine for process failings, but no errors. That function had a complexity of 97, and the people reviewing it said, we can't find anything wrong, but we have no idea what's going on here. So complexity is important, but a switch statement, by definition, has high complexity. So McCabe himself, when he created the cyclomatic complexity measure, came up with another one called essential complexity, which consolidates down things like switch statements into a single block. So again, treat complexity with some thought. So what does complexity tell you? It shows the number of paths through the code. No more, no less. In doing so, it highlights which functions need more attention. So if you have a function with complexity of 30, you probably want to spend more time looking at that than one with a complexity of 5. It gives an indication of the minimum number of test cases. However, absolute thresholds are unhelpful at best, which is why certain tools will allow you to tweak those parameters up and down. The default is just that, it's a default. You need to understand what you should be looking for. At worst, it teaches you to write bad code structure. So I have seen a project where they split a case statement up into 5 functions so that each function came below their in-house threshold of 15. Really not helpful. So, in conclusion, software quality measures or metrics have their uses. They're easily misused. Please remember Goodhart's law, that when a measure becomes a target, it ceases to be a good measure. Thank you very much.